Okay, this is my work for quiz number 5, which is our chapter number 15 quiz. So in this problem, we're told we have this disk that oscillates about an axis of rotation, and we're given an equation for the angular acceleration that is alpha equals negative k theta, which is right here. And we're first told to find out which k value would make these conditions true here that I wrote down. And so I drew a picture of this to kind of visualize it, so we know we have a fixed axis here, and we know that since the angular acceleration we're given is a function of theta, we're going to have to integrate in order to find the solutions that we're looking for. And so the first thing that I did to solve for k is use this information about omega and theta that we were given for this rotating disk. And in order to solve this, this is the equation, the relationship that I decided to use. And so we know that alpha d theta has to equal omega d omega. And that's very similar to the kinematic formulas we used for linear relationships. These are just angular terms. And so plugging in the alpha that we know from up above, which is the negative k theta, and pulling out the constant k that we're looking for, gives us this side of the equation, and then we just leave omega d omega on this side. So we have theta's on this side and omega's on this side. And then the problem gave us our bounds here for omega and theta to solve for k, and so I plugged in those bounds. And then I integrated here and plugged in our bounds, and it was nice that we had two terms that were 0, so we didn't have to really consider those, but that did make this term negative, so we had to be kind of careful. And then just simplifying this gives us this as our term for k that we can put into this equation here for the second part of the question. And so for the second part of the question, the problem wanted us to determine the angular velocity, which is omega, when theta equals 3.5 radians. And so to solve that, we use the same relationship here between theta and omega. And this time we know the k value from above, so we can plug that into our alpha equation that we were given. And then we had to integrate once again, and so plugging in alpha, we can once again pull our k value out, except we know what that is this time. And we will integrate theta on this side and omega on this side. And then as far as our bounds, we're looking for omega when theta equals 3.5. And then I plugged in this point here, which is another point that we were given. So we have both our bounds. And then, just like when we were finding k, we have to integrate again. And so integrating this equation gives us this. And then plugging in our bounds gives us this equation here. And then it was just a matter of simplifying, so adding this term over, multiplying by 2, and then taking the square root, which gives us our final omega term, which is 10.803 radians per second. So that's the answer I got for quiz number 5. And looking at the values here, the initial conditions that we were given, the theta we were given is between these two, and our omega is also between them, so our answer kind of makes logical sense from the information given on the problem. So that's it for this question. Thank you.